Welcome to data analysis scholarship course. This is cohort 2 of data analysis scholarship course. Kindly let me know if you can hear me. Let me know if you can see my screen. I tagged it Data Analysis 101, Introduction to Data Analysis. You are welcome once again. I tagged it Introduction to Data Analysis, Beginner's Guide to Data Analytics. You are welcome to Cohort 2 of Data Analysis Scholarship Training. In this first live session, we will break down the foundations of data analytics, data analysis perfect for beginners who are ready to start up on a journey. What is needed, what is required. Welcome. Let me know if you can hear me. Let me know if you can see my screen. If you are just joining us, let me know in the chat if you can hear me, if you can see my screen. And if you are yet to subscribe, hit the subscribe button so that you can participate live on this section, ask questions, and then get feedback directly as we progress on this journey. This is going to be a 6-week course where we will be learning strictly data analysis using Microsoft Excel tool. Thank you to Daniel Ojo for that. And also, as it will be, we will be taking attendance. Attendance also will be part of the continuous assessment for this professional certification on this course. As you saw in the update in the group, if you are part of the cohort 2 of data analysis scholarship group, kindly drop your name and your scholarship ID right on the chat box. Right on the chat, drop your name, your scholarship ID. And also I will want us to do certain thing this night. We will be going through that as our culture demands. Those in cohort 1, we do that in cohort 1, and in cohort 2, we are going to do that. From what I'm seeing from my end, we are 13 persons on this live call now. Let's head over to the scholarship group, tag as many as possible. If you are hearing me now, get over to the scholarship group. You are welcome. Let's head over to the scholarship group, tag as many as possible. Let's tag everyone. Let them know we are live for tonight's section. Let them know we are live for tonight's section. Hi Danny, you are welcome. Thank you. Ifan is Stanley, welcome. Shedrack Atta, welcome. Good to have us. Let's head over to the scholarship group. Tonight we are going to be laying foundations. Like some of us asked, those that saw me physically and those that chatted me up, some asked, what if I don't know anything on data analysis? And I remember I stated clearly that we are going to be starting from the scratch. I stated clearly that we are going to be starting from the scratch. So let's head over to the scholarship group and tell everyone that we are live. And also hit the like button on this section. That way it will help to keep the channel healthy so that it doesn't hurt the channel. If you are yet to like the section, please go ahead and do that. Also, if you are part of this scholarship, drop it in the chat, your name, your scholarship ID, and where you are joining us from. Tonight we will be having that brief introduction, your name, your scholarship ID, and where you are joining us from. That is part of our attendance. That is part of our attendance. Your name, your scholarship ID, and where you are joining us from this night. Very, very important. Shedrack, good to have you. Yes, okay. All right. Okay, Chuku, Onyelu, Cheya, good to have you. Lua, Yemisi, good to have us. All right, let's quickly do that. If you have tagged people in the scholarship group, please drop in the comment, done. If you have done it, just drop in the comment, done. If you have tagged people right on this section, if you have gone to the scholarship group and you have tagged them, you have let people know that we are live, kindly click on done in the chat. I'm waiting so that we commence. Data analysis 101. What was it, Michael? Good to have you. Your name, your location, and your scholarship ID. Very, very important. Oluwayemisi. All right, Ileife, good to have you. This is part of our attendance. Is part of our attendance. So if you are dropping your name, your location, and your scholarship ID. Let's head over to the scholarship group. Let everyone know that we are live. Very, very important, please. Very much important. Let's do that. Let's do that. We are about to commence. I want to get as many as persons available on this call this night. Emmanuel, it will be good to have you. Your name, your scholarship ID, and the location where you are joining us. Oku Stanley, scholarship okay from Owerri, good to have you. Right there from Owerri, Imo State. Ifeanyi Stanley, Owerri, Imo State, good to have you. Onyelu Cheya, Owerri, Imo State, good to have you. Seems that we are having Owerri here tonight. All right. Having done that, we have given like 7 minutes, 5 minutes, waiting for those to join us. Right now, we proceed. We proceed. Let me give a minute more for others to join us before we kick off. Let me give a minute more. While we do that, please, your name, your scholarship ID, your location. Favor Oba, good to have you from Lagos. All right, we will proceed. It will be from Kogi State. Good to have us. We will proceed right away. All right, let's quickly dive into what we have tonight. Tonight is Introduction to Data Analysis. Welcome once again to Data Analysis course. Introduction to Data Analysis. This training is brought to you by Solomon Institute of Tech and Management. I'm your facilitator, Mr. Franklin. After now, you are going to know a bit about me. Let's drop it. All right, Jibri Esa from Kwara State, good to have you. Sani Folu, Rami Osun State, William Adeloro, Lagos, Badagry, and all that. Good to have us. Welcome fully to Cohort 2 of data analysis scholarship course. Tonight we are going to be laying foundations, and that's why we are looking at introduction to data analysis. Some of us are skeptical whether we are going to start from scratch, whether it will be beginners friendly, and that is exactly what it is a beginner friendly course, and that is why we are starting from the scratch, which is what is data analysis, and then we proceed from there. Once again, you are welcome. Let's proceed and meet your facilitator. Who is this man that you are hearing his voice? That's the picture right there on the screen, and my name is Mr. Franklin Chinedu Wankwo. That's the full name. The C stands for Chinedu, the N stands for Wankwo. And who is this person? I'm a seasoned data analyst and a management consultant. Also, I have portfolios and certifications in diverse as regards to tech, HR, project management, business management and analytics, safety, and the likes. One thing I'm passionate about is to teach, to act, and to inspire others. That's one thing. These are things I'm very passionate about: teaching, acting, and inspiring others. And that is one of the things that makes it that I bring a wealth of expertise to every section, such as the one you are about to witness this night. And one thing I can boldly say is that I'm passionate to teach. I'm passionate to inspire others. I'm passionate to see that I impact and contribute my quota towards impacting fresh minds in data analysis, in management, and as regards to business analytics. These are my major. And one of the things also you know about me, I'm a devoted Christian. I say it without any reservation. I love Jesus Christ. I'm married to the most beautiful woman on earth. So when you are seeing this man on your screen, is behind every successful man, and behind every gallant man there is a woman. That's on the lighter note. And I made no mistake to say that, yes, I'm married to the most beautiful woman on earth. And there are three things I cherish. I cherish faith in Jesus Christ. I cherish family and personal growth. I'm always a preacher of personal growth. If you have known me, some of you that have encountered me personally, you will know that I focus. One of my major drive, passion, is to see that people grow personally, personal growth, personal investment. And one thing I'm going to tell us this night, listening to me, is that make it a rule, which I do. I make it a rule that every year, make it a rule, every year, at least add one skill or knowledge to your skill set or your knowledge set. We have what we call skill set or knowledge set. Like you can see here, I just summarized some major skills and knowledge set I have as regards to the first paragraph of my introduction. Make it your rule. Don't allow anybody to trivialize it. Make it your rule that every year you add at least one skill or knowledge to your skill set or your knowledge set. Make it a rule. That's why some persons see me and they say, you are this, you have this, you are this, you are multifaceted. It's not, it doesn't just come at a goal. It's a process of over the years. Each year, I make it a rule to add skills, to add knowledge to my knowledge set. And if you do that consistently for the next 5 years, for the next 7, 10 years, you will see that when you stand to talk to persons, to talk to people, and to address congregations, to address persons, audience, you are addressing from a point of wealth of knowledge and wealth of skills. And that will make you to standard, to attend to an echelon where persons ought to be. All right, this is a bit about the man that is going to take you through on this journey. I have been a data analyst for over 7 years. I have analyzed different data using different tools, data analytics tools, but to for this scholarship, our focus is to demystify Excel. I always say that Excel is the foundation of every data analyst, and Excel is the highest used software on planet Earth. No software have come close in the usage, in the use cases of its regards to Microsoft Excel. Every company, every organization, the foundation to data collection, the foundation to data transformation, the foundation to data management, all begins from Microsoft Excel. And every professional analyst will tell you, every professional analyst will tell you that Excel remains core foundation, and not just foundation, a core attribute of every analytical process. Excel remains a foundational tool, and that's why no analyst today will tell you that he or she doesn't have a knowledge of Excel. And one of the things I have decided to do as regards to these 6 weeks is to demystify Excel, to take you to different areas where you might have not gotten, where you might not even know that Excel have the capacity to do this. We are going to demystify it from the scratch. If you don't even have any knowledge in Excel, don't bother, don't be afraid. We are going to start it from the scratch. We are going to start from defining Excel. We are going to start from explaining analysis, so you understand what it is. All right, for tonight's section, I have prepared it in 4 modules. I have prepared tonight's section in 4 modules. I designed tonight's section in 4 modules. The first is what we call the overview of data analysis. Overview of data analysis. Then we will move to importance of data analysis. We need to understand what data analysis is and what it entails. Then what importance we have to get. What are the benefits? What are the things as data analysts we intend to enjoy? Then what are the key concepts and terminologies that pertains to data analysis? And when we say key concept terminologies, we are not just talking about only Excel alone, or as regards to data analysis. Whether you are analyzing with Python, whether you are analyzing with BI tools, whether you are analyzing with management, database management, whatsoever analysis you are doing, these concepts and terminologies cut across. And I need to state this, please. I need to state this, that one of the things you need to understand that Excel is not the analysis. Excel is a tool. Excel is a tool, is data analytics tool. So we need to understand that. Instead of us doing it manually, Excel, SPSS, Power BI, Tableaus, SQL, Python, R, and the likes, they are all data analysis tools, which we are still going to get as we progress. So then finally we wrap it up with data collection. We wrap it up with data collection. Explain the things that pertains to data collection, especially those of us in research, those of us that are in academic research or business research. You know how to collect data, how to collect data. There are principles of data collection where we have to respect data privacy. We are still going to get to that. All right, having done that, let's quickly head to overview of data analysis. Overview of data analysis. Let's quickly head over to that. If you are joining us, kindly drop your name, your scholarship ID, and your location. That is one of the ways we take attendance on this course. That is one of the ways we take attendance if you are part of the scholarship program. And also remember to hit the like button on this live session. Very, very important. It helps the channel not to be shadow banned. So please, I will encourage us, don't just be on this live, hit the like button, and then ensure that you follow through. And along the line, I'm going to take also my second attendance for this live session. Okay, overview of data analysis. Definition of data analysis. What is data analysis? What can we define data analysis to be? Now, I define data analysis as a process. Please note that word. data analysis, I define data analysis as a process. Data analysis is the process. So it's not something that is rigid. It's not something that is static. It's a process. There are patterns, there are process, there are methodology, there are systems to which we use in order to analyze data. So data analysis is the process of systematically. You can see that I purposely bold systematically. Why? Because it's something that is not done haphazardly. It's not just you come anyhow, you just say, okay, this is what this will be. No, there should be a pattern, there should be a system, there should be a structure to which your argument, to which your statement, to which your hypothesis, your prediction, your inference, or your statement stands. So data analysis is not just coming to do a guesswork, coming to do a hearsay. It's something that is systematically done. So what is that? Is the process of systematically first collecting. There should be something we will use in order to make certain inferences, certain decisions. So we need to first of all collect it. And what is that we are collecting? Data. So it's the process of systematically collecting data. And you might say, why should we systematically collect data? Just go and collect data now. No. In analysis, data should be well represented so that the decision so that the decision is what we can say is not biased. So as to have a very unbiased decision. So we need to properly collect our data and ensure that our data represents the entire population. We are still getting to that, but systematically we ensure that we collect it effectively. For example, if we want to check the average performance of Nigerian students in the last concluded WAEC examination, we can come to say, okay, we are collecting the data from all the states, from one of the states. Let's say, like in Osun now, and we just collect data from Osun State, and we get the average performance, and we use the average performance of students in Osun State to judge all the students in Nigeria. That data collection is not well represented. So it's not done effectively, it's not done systematically. So what can we do? We can come to Osun State, collect some samples, go to all the states, collect sample results from different local governments of the state represented, and then bring it together and check the average performance. And from there, we can say that the average performance of Nigerian students is above average score and stuff like that. That is when we can say the data is well represented, that the data we collected represent all the states and regions of the Federal Republic of Nigeria. So data analysis is the process of systematically collecting. And when we collect, organize the data effectively. In organizing, we put it in a spreadsheet, organize it, check it, what are the things that are needed, we put what are the things that are not needed, we remove it. So it's a process of systematically collecting, organizing, and analyzing. You organize, you analyze. Some might say, okay, why do you put analysis? That's part of the process as well. Then interpret and present. Now, ladies and gentlemen, I need to state this to you, that interpreting data analysis, one of the things that makes you a core data analyst, in fact, one of the things that makes you a true data analyst is the ability to interpret your data, the ability to interpret and present. Some of us can use Excel to analyze. use SPSS, use Python, use R, use this. But when we get the result, when the output comes, we are confused. We don't really know what those outputs stands for. We don't really know what they mean. We don't really know how to interpret that output and use it to make informed decisions, and use it to uncover insights, and use it to uncover trends. So what truly makes you a data analyst is your ability to interpret and present data. Why I paused a bit is for this to digest. What truly makes you a data analyst, that you go out and flout yourself that I'm an analyst, is your ability to interpret your result. So when you collect data, organize it, what we call data management, data organization, and then you analyze that data. And the result you got, the output that you got, the ability for you to interpret it, understand their meanings, and interpret the output, the result, and present it in such a way that is decision making, in such a way that you predict outcomes. That is what fully makes you a data analyst. So having established that, we now conclude. Let me read it all through now. Data analysis is the process of systematically collecting, organizing, analyzing, interpreting, and presenting data. For what purpose? For the purpose to uncover meaningful patterns, so that we can predict trends and insights for decision making. Now, having established that, we said it involves applying statistical, please get that, involves applying statistical, mathematical, and computational techniques to raw data. What statistical means, we need some statistical understanding. We are not going to be saying you need to learn statistics. No, we are not saying you need to immerse yourself in statistics. No, there are basic statistics you need to know. There are basic statistics you have to know. That's what is required. Basic statistics, your average, your mean, your standard deviation, your variance, your mean square, your standard error of mean, all those basic statistics. We are not talking about you going to gamma laws and all that. No. Those basic computation, the mathematical is your ability to understand basic maths, basic arithmetics, basic laws of some we call it pendants, some call it board mass. That basic law, the Boolean algebra, the mathematics of 0 and 1, the probabilities in 0 and 1, the basic maths, then computational techniques, the ability to use softwares, the ability to use softwares in other techniques to raw data. Raw data is data that has not been used. That's raw data. Data that has not, raw data is what has been used. You are using it for a purpose. You haven't transformed it. You haven't analyzed it. That's raw data. So to raw data, to convert it into actionable information that supports decision making, problem solving, and forecasting. This is the definition of data analysis. Let's proceed. Now, having established this, we are moving to next, which we have as types of data analysis. If you are with me and you are part of the scholarship group, kindly drop your name if you haven't done that. If you haven't done that, if you have done that, beautiful. If you haven't done that, your name, your location, and your scholarship ID. And one thing I will request from us on this live is to go ahead and hit the like button. Very, very important. I will appreciate that we do that. I will so much appreciate that we do that. Go ahead and hit the like button for this live session and then share this session. Please, I will encourage us to do that. Share this session. This is one of the things I will encourage us to do. Share the section, like it. It helps to build the algorithm on YouTube. Please, very, very important. All right. We are going to be looking at types of data analysis. Types of data analysis. In data analysis, in types of data analysis, I summarize the types into 4. I summarize the types of data analysis into 4. These are 4 major types of data analysis. The first one is what we refer to as descriptive analysis. The first one is what we refer to as descriptive analysis. Now, what is descriptive analysis? This, as the name implies, descriptive is of analysis that deals with what we can see, that deals with what we can feel, that deals with what we can count. What we can see, what we can feel, what we can count. So we can see the number of students on this call now. We can say by so time, we can say, okay, we might say, okay, let's compute the number of students on this live session at every 5 minutes interval. So at 5 minutes, we take record of the number of students on this live. That is descriptive because it's something we can see. We can see it as the life is going and say, okay, on this live, so number of persons are alive. We can count it. It's a statistics that deals with what we can see, what we can describe. You can look at somebody and you say he's putting on a red shirt. That's descriptive. You are describing the color of shirt. The persons that there are 5 females on this, there are 5 females in class and 7 males. That's descriptive. So when we talk about descriptive statistics, descriptive analysis, it's an analysis, it's a statistics that deals with what we can see, what we can count, what we can feel. So if we can feel it, we can describe it. That's why it's called descriptive. And it's analysis that focuses on the past. Analysis that focuses mostly on the past data, historical data, past data. When you look at this, and also a kind of now. So in descriptive analysis or in descriptive statistics, there are 2 types of descriptive analysis or 2 types of descriptive statistics. Most of us on this call, you already know your basic mathematics. Even in SS class, secondary schools, you have descriptive statistics. You know 2 types of descriptive statistics. So I will want to ask, drop in the charts. Someone drop in the chat what are the 2 types of descriptive statistics. Let's do that. The first, check your network. Okay, Chuku, check your network. I think from my end is okay. If from my end is okay, you are saying the audio is breaking. I think from my end is okay. Check your network, please. Check your network. Okay, let's on the chat now. Let's bring it on. What are the 2 types of descriptive statistics? Someone drop it in the chat. The first person to do that might win something this night. Might get access to certain things, something this night. The first person to drop it in the chat and get it correctly. 2 types of descriptive statistics. 2 types of descriptive statistics. The first person to answer that drops it in the chat and get it correctly, we get something from me. And please remember, you have to be part of the scholarship. Some persons are saying inferential statistics, no. Favor saying qualitative and quantitative, no. 2 types of descriptive statistics or analysis. Let's do that. The first person to get the answer, you get something from me this night. You get something from me, be part of the scholarship as well. I'm waiting. This is basic mathematics. It's not advanced statistics. So it's not advanced statistics. If you are just joining us, your name and scholarship ID very much appreciated, and also ensure you hit the like button on this live section. Very, very important as well. I'm waiting for us. I'm waiting for qualitative and quantitative. No. It's not. Who else? Inferential statistics. No. Two types of descriptive statistics. Under descriptive, we have two types. We are still in descriptive. Under it, we have two types. And don't do, please, under God, don't do any expo. Countable and no, it's not. Okay, I think the time is fast spent. Now, under descriptive statistics, we have what we call measures of central tendency. You have that. Under descriptive statistics, we have what is called measures of central tendency. You might have had that in mathematics. That is SS2, SS3 maths in secondary school. It's not even, it's SS2, SS3 maths. Two types of descriptive statistics. Measures of central tendency, which under measures of central tendency, it checks how concentrated the data is at the center. That's why we call it measures of central tendency. I have already started saying it before all these answers start coming. I even said two. Okay, some say finite data and countable data. No, under the two types of descriptive statistics, we have measures of central tendency, which deals with data that checks how concentrated the data are at the center. That's measures of central tendency. Then the second one is measures of dispersion or measures of spread. Measures of dispersion or measures of spread. That's the second type of descriptive statistics. Descriptive statistics is in two types. Measures of central tendency, where we have mean, median, mode. You remember that in your basic maths or your basic statistics, mean, median, mode. That's for measures of central tendency. Then when we talk about measures of dispersion or measures of spread, we are talking about the range, we are talking about the standard deviation, the variance, the quartiles, and the standard error of mean. They are all mean deviation, rather, not standard error of mean. Mean deviation, they are all under the what do we call it, measures of spread or measures of dispersion. All right, that's what we have. That's what we have as regards to that. We are not even in single variable and by variable. We haven't gotten to data and variables. We are talking about analysis. We will still get to what data is, types of data, and then variables. We are getting to that. Some of us are confusing the two. We are not talking about data. We are talking about data analysis. We have descriptive analysis. Under it, we have measures of spread, measures of central tendency, and measures of spread. Measures of central tendency deals with mean, median, mode. Measures of spread is standard deviation, variance, and the likes, range. All right. Now, having established that and having explained what descriptive analysis or statistics is, we move forward to the next one, inferential analysis, or what you can call inferential statistics. Now, under inferential statistics, or what you can call diagnostic analysis, what you can call diagnostic analysis or inferential analysis, is an analysis that deals with educated gaze. What do I mean? It's analysis that deals with educated gaze, that that states prediction, that make a statement that is not certain, makes an uncertain and unverifiable statement, then we can now analyze to check whether that statement is true or false, whether that statement will be accepted or not, whether that statement will stand or not. That's what inferential analysis is. It's an analysis that deals with educated gaze. That's where we begin to talk about hypotheses, making hypotheses, stating hypotheses, stating statements, making observations, and then from that observation you make a statement, you make a hypothesis, you state certain stuff that you are not, you from your observation, not just coming anytime and make a statement. No, from certain observation you can now make a statement, state a hypothesis. That's what we call it. An unverifiable statement that is backed with observation. You make that statement. The next thing we do is to now take analysis, to take certain tools to analyze, to know whether that claim will be accepted or not. To know whether that claim will be accepted or not. That is inferential analysis. Shadrach, I'm seeing what you are doing. Thank you for putting that update. I'm seeing that also, and who else does that? John Kane. Good to have us on that. Thank you for updating on charts. That is beautiful. That's a beautiful approach. All right. Inferential statistics or inferential analysis, like I said, is an analysis that deals with educated gaze, educated statement, educated gaze, and on that observation, you make certain inference, you make certain statement. And under inferential analysis and under inferential statistics might be your network. Uduma, it might be your network. It might be your network, Uduma. Please check your network. It might be your network. Is very good from my end here. I think from my end everything is going well. So check your network also. All right. Now under inferential analysis or under inferential statistics, we have two types of inferential statistics or inferential analysis. I will be using those two words interchangeably as regards to these types of data analysis. I'm going to be using them interchangeably. All right. Thank you, Precious Chedema, for that update as well. Okay. Now, I'm also going to give another privilege for someone to win something this night. Who can tell me two types of inferential analysis? I have already said these two. Under inferential analysis, there are two types of inferential analysis. So can someone on the chat, the first person to get the two types of inferential analysis gets something from me. Get something from me. The first person to do that in the chat gets something from me. The first person to state two types of data analysis, inferential analysis rather. There are two types. The first person to state it in the chat, the two types of data analysis, gets something from me. And while we wait, if you are yet to like this live session, please, I will encourage us to hit the like button. Also, if you know any place that can be part of it, you can also share the live session for them to be part of it. And then when you say correlation analysis and regression analysis, no, that's not is. Those are stuff under inferential analysis, but they are not the two types. Tillman Lawrence, qualitative and quantitative, no, Bible verse daily. Tillman Lawrence, hypothesis testing and regression analysis. Tillman, you got one, you didn't really get the other. I will give you the hypothesis testing. It's called hypothetical testing. It's called hypothetical testing. Further, we said estimation and hypothesis testing. If I Stanley said estimation, I have okay. Further, but let me declare you the winner, though you didn't really get the full name. Is called estimation of parameters. It's called estimation of parameters and hypothetical testing, or test of hypothesis as well. Is either you call it hypothetical testing or test of hypothesis. So is the two types of inferential analysis. I love our engagement. The two types of hypothetical inferential analysis is hypothetical testing or test of hypothesis and estimation of parameters. That's the name, estimation of parameters and hypothetical testing. Now, under hypothetical testing, that's where we test hypothesis, check the null and alternate hypothesis. We are going to get to that as well. So these are the two types of inferential analysis or inferential statistics, test of hypothesis or hypothetical testing. Either you call it test of hypothesis or hypothetical testing and estimation of parameters. All right. Now, having explained that, the next one is what we refer to as predictive. Predictive is a type of data analysis that forecasts for future. It forecasts for future using forecasting tools and machine learning to design a predictive model. But like on this session, we are going to be looking at regression analysis as a predictive model. We are going to be looking at how to use regression analysis to state a predictive model in order to make informed decision. So in predictive analysis, is a type of data analysis that makes use of historical data in order to make a statement for the future, to predict future occurrence. So it leverages on historical data. It leverages on past information, past data, in order to make a decision for the future. That's why we call it predictive. Ability to forecast. The ability to forecast. That's the predictive analysis. That's the predictive analysis. Now, the fourth one is a more advanced aspect of analysis that uses predictive tools, doesn't just only predict, but give recommendation of the solution. That's where designing machines and automations using machine learning to design an automated model in order to prescribe certain cure for diseases, or not just predicting the time of occurrence, or not just predicting outcomes, also make prescriptions, make recommendations, state solutions, give solutions. So that's where we begin to look at AI models, machine learning models that we can use not just to uncover trend, but to also state solutions as regards to what we have. And this aspect of prescriptive is currently now mostly used in business, health sector, logistics, even in telecommunication, especially in health. That's why if you are in health, you will see there's a lot of integration of AI models, machine learning, and predictive models in order to be able to state solutions for certain ailments, for certain diseases, to see solutions for certain diseases. So this prescriptive analysis is a more advanced data analysis that requires data programming, machine learning, and even AI integration and automation. Now, let me explain it as in a way we understand. Let's say a doctor comes and check you from check you and ask you certain information. History about the ailment, how are you feeling, so this. He's getting past record, past information, and then using it to make some prediction. Okay, by so time this symptom should come, this will happen. Then if it happens, take so drug. He's prescribing. The doctor is making prescription for the solution. Why? Because he already have information. He already has a solution what can be done. So the same thing is in analysis, where we use analytical models in order to prescribe, in order to give solutions to certain events, to certain challenges, to certain output. And these are the major or the overall 4 types of data analysis. All right. Favor, I think Favor, you are the one that you have won stuff from me this night. I believe you are part of the scholarship. If you are, chat me up after this section. Chat me up with your name and your scholarship ID. Very important. All right. Okay. Now, having done that, let's proceed. Objectives of data analysis. What are the objectives of data analysis? What are the objectives? Why do we go into data analysis? The first one is to support decision making. That is one of the core reasons data analysts are highly sought after, because from the data collected, they can interpret data and make informed decisions, write certain recommendations based on their understanding of data. So is one of the key objectives of data analysis is to support decision making. The next is to predict outcomes. Remember, we have what we call predictive analysis to forecast what will be our profit margin by 2027, what will be our average sales by 2027, what will be our marginal annual return by so time, to predict outcomes by the use of data analysis. All right, the next is to validate hypotheses. Remember, we make certain statements, we make certain claims. We need to analyze our data to see whether that claims are valid. So to validate hypotheses. Next is to measure performance. To know whether we are growing or not, to know whether we are making progress or not, to know whether we are making profit or not. On the paper, you might think we are doing well, but when analysis are being done, we most likely to uncover some hidden aspect as regards to that analysis, as regards to our data set. So to measure performance is also one of the keys. Is also one of the key objectives of data analysis. The next one is to drive innovation. On Thursday, I'm going to be starting Excel from the scratch. You don't even dare to miss that one. That's the foundation. I need to say that now. I forgot to say that before. I need to say that now. In fact, I'm going to be unveiling Excel in a dimension that you might have not seen it explained. I'm going to take my time. In that first section of data Excel, I'm going to take my time. So those of us who are beginners, those of us who are new, and even those that think you are Baba, yes, all of us are Baba, but there are certain things I'm going to be unveiling. Mark my words. All right. The next key objectives of data analysis is to drive innovation. That's why when you uncover trends, understand how data is, it drives innovation. Now, let me give you one example of innovation. You know, before now, there is nothing called Facebook Reels, YouTube Shorts, all these short stuff. Now, what brought that innovation is having to have a collect data to see that people attention retention is going down. People like something sharp sharp. Why? Because of data collection of people attention span to a particular content. Now with that, it brought up the innovation of, okay, you can just summarize your information in a minute, in 2 minutes, within a minute and 30 seconds. You can summarize your information and push it out there. Let the person consume it. Don't just beat around the bush. Go straight to the point. Those who want straight to the point will take it. Those who need further explanation will go for long form videos. Is from data analysis, collection, and uncovering insight, understanding people's behavior by the virtue of analytics. People analytics on the site, on the internet. That is what brought that innovation of Reels, YouTube Shorts, and what have you. So it drives innovation. From data analysis is a core driver of modern day innovations, modern day creativity. Data analysis does that. Also, enhanced data quality. Enhanced data quality. Your understanding of analysis will make you to ensure that when you collect data, that data is quality enough to have standard representation, so that it removes biasness. It removes biasness and gives us what we refer to as unbiased result. So it enhances data quality, and then identify patterns and trends. This is very, very much important as well. Identify patterns and trends. What with this, because if you check in Nigeria, we have 2 major seasons, the rainy season and dry season. So based on patterns, we know the time of the year when rain should be, when rainfall will be very high, and time of the year when dry season, cold will be high, hot weather and all that. No patterns. And then with that patterns, we can plan. You can use it to identify patterns and trends. During festive period, our sales shoot up. So during festive period, we need to stock. We need to stock our office, our shop, or we need to bring in more hands that will help during that festive period. Why? Because of patterns and trends. Without it, that decision will be difficult to make. That decision will be difficult to make. So when we are looking for, when we are talking about this, identify patterns and trends. Why? In order to make certain decisions, to take certain actions. So that's not then improve customer understanding. I have just given us aspect of YouTube. Those that comes to YouTube to watch, they are customers as regards to YouTube platforms. So with data analysis, it has to give customer understanding. At the same time, those in sales, retail businesses, it has to understand the kind of product the customers goes for more. The color the customers goes for more. Let's say you buy the same product but different colors. This one red, green, white, and that. And you notice that you need to take your data from your data, the sales. That's why stock taking, inventory management is also part of data analysis. Those in taking inventories, those in taking stock should also know, okay, this color. From it, anytime we bring this stock, this color is the first to finish. This color of product is always the first to finish. So we can be able, the next we are going to market, please buy this color more. People are looking for this color more than this. That's from a data collection, and then you study, analyze, and get it. But if you don't collect your data, there is no stocking, you don't really take care, you just sell, you might miss that information. You might miss that understanding. So when you understand your customer, it will help to improve your customer service. And then finally, identify risk and opportunities. That's in data analysis. Identify risk, identify opportunities. When we talk about risk here, we're talking about negative impact, things that will impact us negatively. Opportunities, things that will promote us, things that will benefit us. So those things that will benefit us, how we can maximize it. Those things that will harm us, how we can prevent them. Data analysis helps us to do that. So these are the key objectives of data analysis. These are the key objectives, 9 key objectives of data analysis. All right. Now, having established that, we move to the next, which is importance of data analysis. We move to the next module, which is importance of data analysis. Now, under this, we are going to be looking at role in decision making. What role does data analysis play in decision making? So, one of the key importance of data analysis is its role in decision making. Its role in decision making. And what are the role it plays in decision making? First, it gives us informed decision. It helps us to make informed decision, not just making decision, a decision with a data to back it up. You are saying our sales will go up by so time. Are you just saying it? What data do you have to back up this statement so that we can make this decision? You are saying customers influx, customers inflow will be so high by so time. What data do you have to back up so that when we are making decision to bring in ad hoc, to bring in contract staff, to bring in part-time workers to help serve our customers, we are making it based on data. So one of the roles it plays in decision is that it helps in informed decisions. Informed decisions. Then the next is what we refer to as risk management. The role it plays in decision management is, secondly, the ability helps us in managing our risk. How we can navigate, how this one is not really something that will be very detrimental. We can focus on this one while we mitigate this. Risk management. So because we have data at our disposal, it helps us in risk management. The next one is what we call strategic planning. We cannot overemphasize on this one. Because of data, because you have access to data, you can make strategic plans. You can make strategic plans. When we talk about strategic plans, plans that is backed up with data, not just plans that what you feel. I feel by December things will turn up. I feel from October. No, you don't feel. Check data, get information, get data, analyze it, see the trends, check what happens. It might be that by that December, that during that festive period, for the kind of stuff you are in, things are going down. Not every people experiencing stuff moving up during festive period, during seasons. So it helps in our strategic planning so that we know when we can give promo, when we can give discount, when we can recruit, when we can put persons on the standby, and those decisions in our strategic planning. That's why if you are a HR on this call, if you are a business person on this call, any person on this call, one of the core things that data analysis is in that strategic planning. That's why companies that understand integrate human resources as part of their strategic planning, as part of their strategy development aspect. Because humans are those that carry our strategy. And a HR need to understand business analytics and data analysis. Why? Because of strategic planning. You know, in strategic management, one of the core aspects of strategic management is to gain competitive advantage. If you are asked to explain strategic management in one sentence, is to gain competitive advantage in the market. That's just that. the whole essence of strategic management, if you are asked to summarize it in one sentence, is to gain competitive advantage in the market. And gaining that competitive advantage, you need data to support your plan and your decision. So, strategic planning. Next is performance management and performance measurement. Performance measurement, data analysis, the role it plays in performance in making decisions as regards to performance management cannot be overemphasized. Let's quickly move to that. Customer insight, we have also talked about that in the previous session, in the previous module, customer insight, so that we understand our customer more and know how to make decisions. And one of them is that when you apply the Pareto law, where the law of 80-20, you know the customers, they ask, or the demography of customers, the location of customers, the aspect of customers that brings you the more inflow, the more income, and you focus in servicing them. You focus in maximizing that demography of customer. Let's say your business, you notice that those that patronizes you more are between the age bracket of 20 to 30. You look at what do they like, what are the things that trigger those people, and then you look at how to serve them effectively. Why? Because they are the pillar, they are the major persons that bring in profit or inflow in your business. So using data analysis, it helps you to get more customer insight. And then as you get the customer insights, how to serve the customer effectively. All right, and then we wrap it up with the competitive advantage. Like I talked about in strategic planning, the whole essence is to gain competitive advantage. That is one of the key importance of data analysis. It plays a role in decision making. Its role in decision making, and it goes across this hexagon. It goes across this hexagon. All right. We are making progress. I should finish this before 10, and then or within 10, it should be a 2-hour section. Okay. The next is to look at application in various industries. That's another importance of data analysis, is application in various industries. One of the things that makes data analysis a highly sought after course, a highly demanded course, a high income generating course, is because of its application to virtually all industries across. Why? Because no industry today can stand or can exist without data. It's nearly impossible. No industry can exist today without data. Nearly impossible. So what that simply means is that because of the application of data analysis in various industries, it makes it one of the highly sought after course across the globe. And one of the beauty of it is that this thing is something we can do from the comfort of our bedroom, from the comfort of our home. That's why data analysis tech is very, very beautiful. All right, now having said that, what are these applications in various banking, in please let me know if you can hear me. We are moving forward. Let me know if you can hear me. Like I said, number one is healthcare. We apply application of data analysis in healthcare, in finance, banking, all those. All right, beautiful. Thank you for the feedback. All right, beautiful. Okay, now the next is in retail industry, real industry. The companies like the Walmart, The companies retail businesses, Walmart, like ShopRite, all these supermarkets, all these big superstores, they are retail industries, they are more on retails. And they make use of data analysis so much. They know when to give discount. They know when to give promo. They know when to apply buy one and get one free. This product is about to expire. This product in 3 months is about to expire. So let's push it forward. Let's encourage people to buy it. So with that, how? Because of data analysis. They use data analysis effectively. Thank you, guys. All right, the next one is what in manufacturing industries. Data analysis in manufacturing industries to make some decisions in quality management, in quality assurance and quality control, and in stocking, in warehousing management as regards to manufacturing. Data analysis is also applied. Then we also have education sector. Of course, analysis, data analysis is highly applied in that aspect, in that sector. Effectively, an educationist must have data analysis skills to rate students' performance, even to observe certain teaching patterns or teaching strategy, to know from analysis which one works best for some set of students. So that also is applied in transport and logistics. Is also applied there. Also, we have in telecommunications. Data analysis is also applied in the telecommunication. Database management is analysis in telecommunication. How do they process various data, calls, charts, messages, and all that in real time? That's part of data analysis, data engineering. So those are also applied in the telecommunication. Another aspect in energy sector, energy industry, and then we have entertainment and media. Of course, like I said, in this place where you look at the media, your social media, and the likes, is data analysis is also applied. When you go to Facebook now, you go to your dashboard and you see your analytics. What are those analytics? Is there how many persons visit your page, how many persons respond to your page, how many persons respond to your posts, watch your videos, and what are you? Those are data. They are data. And from there you can see how your channel, how your page, how your profile is doing. And you see things you are doing that works and things that doesn't really work, and things to focus and things that you really need to look at. That's data. It's not too big English. It's data analysis. All right. Now, having stated that, we proceed to the next aspect of data analysis, importance of data analysis. We are going to be looking at key benefits of effective data analysis. Please note one thing here. The key word there is effective data analysis. Benefits of effective data analysis. If it's not effective, you are getting a biased result. So, benefits of effective data analysis. Let's take note of that. All right, what are the benefits of effective data analysis? The first one is increased revenue and profitability. When you leverage your data analysis effectively, there is a tendency of your profit and your revenue increases in business, in any sector. Because one thing I always tell my students when we talk about maybe in management and business analysis is that there is one challenge every sector, there's one problem every sector has. Every sector, every business. And what is that problem? Profit maximization and profit maximization, increase in profit and decrease in expenditure. If you can help organization to increase profit and then reduce expenses, you are an asset to that organization. So One of the key benefits of effective data analysis is increased revenue and profitability. All right. The second one is customer insight and satisfaction. These are key benefits of effective data analysis. You have customer insight and satisfaction. Why? Because when you know your customer behavior through informed analysis, through data, hence you make certain informed decisions that benefits your customer, then that is what we refer to as customer insight and satisfaction. Then the next is competitive advantage. Effective data analysis gives you competitive advantage. While your competitors might be doing things that doesn't really work, might be doing hit and run, might be doing things based on what they feel, you are taking actions, you are taking decisions based on data, based on information, based on things which you have already found out via data that is most likely to occur. So it helps to give you competitive advantage. Then the next one is what we call better financial management. As a good analyst, it helps to manage your finance, whether your own, whether the company's finance, whether it helps in better financial management. These are key benefits. All right, we are not going to spend much time on this. It helps to enhance productivity as well. Using data analysis, it can help to enhance productivity, either by your staff or what you are doing, to know the staffs that are doing well, the area this person is doing more well than this area. So you put him in his area of strength where he will perform very well. And with that, productivity will increase. But if you don't really have data and know where and what the person can do, and where and what the person can not really do very well, you might be placing that person in an area where you will not utilize him fully. So it enhances productivity. The next is what we call improved quality and compliance. And then we also have what we call strategic partnership and collaboration. These are benefits of data analysis, and it brings about innovation. These are in key importance of data analysis, the benefit we have. All right. Let's move to the next. Common tools. The next thing we are going to be looking at, common tools for data analysis and their uses. Common tools. What are data analysis tools? And what are their key uses? Common tools for data analysis and their uses. Okay, the first one we have is Microsoft Excel. We have Microsoft Excel. And what are the key uses of Excel? To show you that Excel is so vast, Excel is so powerful. Excel is used for data entry, cleaning, data transformation and management. I didn't put that one here. It's for data transformation and management. Data visualization. We will talk about your chart, your pivots, your chart, your dashboards. One of the things we're also going to learn on this course is how to visualize, how to present your report, your output in a very dynamic way, in a highly effective dashboard that looks professional and straight to the point. That's chart, pivots, descriptive statistics, forecasting, regression, and modeling. Excel can be used to do all these. Modeling can be business modeling, financial modeling, and the likes. It does a correlation, inferential analysis, the t-test, the ANOVA test. Excel does that as well. Now, one of the things is that it's best for beginners to intermediate. If you are coming into analysis, data analysis, newly as a beginner, Excel is the best part to start. Like I said earlier, it's best for beginners to intermediate. If you are starting with analysis, and that's why some persons that doesn't have strong foundation in Excel, they lack certain foundations. They tend to fluctuate in their data analysis journey. So that's why any analyst, they start up, the roadmap, the first port of call is to start from Microsoft Excel and master it effectively. And it's best for small to medium data sets. Why? Because Excel spreadsheet is limited. Excel is limited to 1 million and 1 point something million rows of data. 1 point something million rows of data. When we get into that we will explain further. All right. The next data analysis tool is the one we call SQL. SQL means structured query language. SQL or SQL. Some call it SQL, some call it, but me, I call it SQL. It's an acronym that stands for structured query language. It's a language we use to communicate with the database machine. So what do we use it for? Data extracting, filtering, aggregating, joining large data sets directly from databases. So we use SQL to be able to extract data, to filter, to do certain analysis, join tables, large data sets. You can use to join hundreds of millions of data, but Excel cannot join 1.1 million. You cannot use 1.1 million data in Excel, though there are certain add-ins you can put in, and then you use unlimited data sets as regards to your analysis in Excel as well. All right. Okay, the next in best for working with relational database and big data storage. That's why banks, this SQL helps in that for big data storage. That's why when you are designing websites that you learn database, relational database, or you learn non-relational database like the MongoDB and the likes. But SQL is a relational database, and then Microsoft Access is another relational database. But Microsoft Access has kind of limitation. All right, we are progressing further. Then the next one is the BI tools, business intelligence tools. And one of the powerful business intelligence tools are Power BI or Tableau. But I use Power BI. I know the tool, but mostly currently Power BI is mostly used by companies across the globe. So these are BI tools, business intelligence tools. So its main uses is for data visualization. You see that Excel can visualize. There are certain things Excel can do, Power BI will not do. There are certain things Excel can do, SQL cannot do. But Excel, you can use Excel for your database management. If it's a small or medium data set, you can use it for data management. In a way, you can do that. So Excel is highly needed across board. So Power BI or Tableau is uses for interactive dashboard, real-time reports, advanced visualization. This is where it has more tools than Excel. There are some charts, there are some visualization tools that it has that Excel doesn't have. And then business intelligence reporting, real-time. So Power BI and Tableau, best for communicating insights with management and stakeholders. That's why it's needed across businesses, across industries. Best for communicating insight with management and stakeholders. All right. The next tools for data analysis is Python. That's the next tool for data analysis. Python. And what is it for? You can also use it for data cleaning with pandas. We can use it for advanced statistical modeling, machine learning, because Python programming can do a lot. It can do data cleaning, it can do data science, it can do data engineering, it can do data programming, software development, even website. So it has a lot. Even cyber security, ethical hacking, there is also Python in it. So all that, Python is a language, it's a very programming language where is used for all these machine learning, predictive analysis, like I talked about, automation, and then visualization, where you use your matplotlib and then see done for your visualization automation. So it can use to automate, it can use to state some prediction. So it's best for large data sets, automations, and advanced analytics. Advanced analytics, automation, large data set, Python is best for it. Then the next one we have is SPSS. It's also a data analysis tool. SPSS, which stands for Statistical Package for Social Science, uses for surveys, hypothesis testing, where we have the t-test and over correlation. Excel can also do hypothesis, Excel can also do the t-test and over correlation, but not as SPSS does it. SPSS is very, very good at that. And then regression models, social science research. And this is best, those of us in academic research, social scientists, business research, researchers. SPSS is a tool that is highly needed. It's owned by IBM. IBM has SPSS. Okay, now the next tool for data analysis is R programming. R. These are core ones. You master these ones. Python, Power BI, R, SPSS, and other. These are core tools for data analysis. So for R, there are other ones anyway, let me know, but these ones are the latest, the trending, the mostly needed across industries. We have Stata. Some of us might have heard of Stata. Some of us might have heard of eView. Some of us might have heard eVideo, APinfo. Those ones, old analysis tools. If you are part of old school, you can remember APinfo. You can even remember Stata. You can remember eView for those in economics. Those old school, and they are still in use now, but not as these ones. But not as these ones. Yes, R is optional to Python, of course. We know, you know that. Okay, now as you can see, also its uses for statistical analysis, testing, machine learning, visualization, academic research. So it's also best for statistical heavy analysis and research field. So if you master Python, I will not tell you to go for R. You can go for R as being analyst. Okay, if you are called in this aspect, you answer. If you are called in the other aspect, you answer. So you can learn, you can get, but it's a gradual process. You can know all these. By God's grace, I have them. I'm by God's grace. So you can learn all these. It's a gradual process. It's a gradual process. It's not something that will happen at a go. Rome is not built in a day. All right, let's progress. Let's proceed. All right, we are making progress. The next we have is key concept and terminology. That's the next place we are moving to. Key concept and terminology. Key concept and terminology. Now, under the key concept and terminology, we are going to be looking at data types. Data types. Data types. One of the things we need to understand that in data types, we have two types of data. That is when we were talking about, I forgot to ask this. When I was talking about a descriptive inferential analysis, these are what we are telling me then. The first in types of data, we have what we call the qualitative data, which has to do with a non-numeric data. Qualitative data, it has to do with non-numeric data. Now, what do we mean by non-numeric data? Is simple. They are data that are not numbers. when you can talk about descriptive, when you describe this, this is white, this is blue, this happens, this once it's not numeric, is a qualitative data. So under data type is summarized into two. When we talk about data types, it's summarized into two: qualitative data, with their primarily non-numeric data. You use it to explain. You use it to explain, to discuss in-depth stuff about the result. That's qualitative data. Then we have what we call the quantitative data. Now, under the quantitative data, as we can see, it's all about numeric data, numeric data. Once it's number, whether in decimal, whether in fraction, whether real number, whether real number, integer, ratio, decimal, root, what's this type, what's this number type, complex numbers, they are all quantitative data. They are all quantitative data. All right. These are two types of data. Okay, now let's move forward. Variables is another key terminology. Variable is another key terminology. Variable is another key terminology. Now, before I proceed, what is even data? Let me not assume that all of us on this call know what data is. Assumption is the mother of frustration. I always say this: when you assume a lot on things, most times you get frustrated. Assumption is the mother of frustration. So let me not assume. Now, data is raw facts. Data is regarded as raw facts or unprocessed information or distinct piece of information. These ways you can define data: raw facts, unprocessed information, or distinct piece of information. So when we talk about data, it's raw, more like crude oil. When you process it, you will begin to get the petrol, the diesel, the kerosene, and the like, the gasoline, and other products from it. That's what the data is in its raw state. So when we analyze it, we begin to get certain information, certain output, certain results. All right. Now, variables. When we talk about variables, we have that variables, under variables, we have what we call the independent variables. We will be making use of this as we progress in this course, the independent variables, because when we analyze data, we will be looking at variables. Variables in analysis are stuff that have more than one characteristics. Constant is one. Constant means is this. There is no change. This is constant. But a variable have different characteristics, have different output, have different characteristics. For example, if you have gender is a variable. Why? Because it has two characteristics or two aspects, which is male and female. It's a variable. You have academic qualification. It's a variable because there are no qualification, primary school, secondary school, and the likes. So variables have different characteristics, but a constant is a constant. Like when you look at acceleration due to gravity, G is a constant, bam. And that in secondary school you are saying is 10, and later you begin to have it to be 9.78, 9.8, and the likes. It's constant. It doesn't change. So variables have different attributes. Now, under this variable, we have the one we call independent variable. Now, independent variable are factors, are predictors. They are what we can call factors. They are what we can call predictors. They are what we can call what other name I've forgotten. Other name we can have forgotten the other one. But in analysis, it's either an independent variable, you call it a factor, or a predictor, or independent variable. In other words, it doesn't depend on what you can see in a study examining the effect of study time on test score. So the effect of study time, the study time here is independent variable. The test score is dependent. So we are checking, we want to check whether the amount of time students give to their Can we hear me? Can someone let me know if you can hear me? Let me know whether the network challenge is from my end here. Please drop in the chat. Drop in the chat if you can hear me, please. I want us to finish this section. All right, beautiful. I want us to finish this session. Let us 10 o'clock to finish the session today. Okay, independent variable. Independent variable is the variable that is manipulated. I put it here, or categorized to observe its effects. To observe its effects on another variable. To observe its effects on another variable. So one of the example is if we are checking the study, so the study time is independent variable. Exam score is dependent. So that's what we refer to as independent variable. And I said independent variable, we can call it factors. Factors, when you look at, when you say factors that can affect, factors that can impact, those factors that can impact, affect, are independent variables or predictors. So that's what we refer to as independent variable. Then the next one is what we call dependent variable. Dependent variable. Now this is the variable that is measured or observed to assess the effects of the independent variable. Is measured or observed to assess the effect of the independent variable. This cannot be overemphasized. I have already explained that the exam score is the dependent variable. To now check what effect does the study time has on the exam score. So the test score or the exam score is the dependent variable. It's a typical example when we say y equals to ms plus c. The y there depends on the value of x in the equation in order to have its result. So y is a dependent variable, yx there is the independent variable. All right, then we have other variables. We like those of us in programming, you have what you can call what we call control variable, confounding variable, moderating variable, dummy variable, mediating variable, variable distributions, and the likes. These are other variables, but in analysis, the one we use mostly and pay attention to is the dependent and independent variable in data analysis. Okay. All right. Now, having established that, we will proceed to the next aspect on this module, population versus sample. Remember, in this module, we are looking at key concepts. We are looking at key concepts as regards to population, as regards to data analysis. One concept you will understand, you will hear in often is population, and then the concept of sample. You will be hearing the samples, this sample data, this sample data set, sample statistic, this, or the population mean, the population this and that. You will be getting to hear much of this. These are key terminologies and concepts. So the first is, what is a population? The population is simply the entire data set of that particular item of study. The entire set, the entire data set of individual or items that is the subject of study. Let's take for example, if we want to look at the academic performance of SS3 students in Osun State, note that if we want to check the academic performance of SS3 students in Osun State is the state in consideration. Now, the population is all the SS3 students of Osun State. That's the population. So for us to analyze that result, we need for us to analyze it and get the average score and other details we need all the secondary school, all the SS3 students, their results. Hence, it might be difficult for us to get all of them. It might be difficult. So what you see here, all students in a particular school, that's a population of the school. That's a population of the school. Every car manufactured by a specific company in a year, that's a population of the number of cars manufactured. So when we are talking about a population, the entirety of the data available in that particular subject of study. So what are the key characteristics of a population? Population is complete and is fixed. It doesn't Please confirm if you can hear me now. Please let me confirm if you can hear me now, please. And when you confirm, kindly let me know why you stop hearing me. All right. Thank you. All right. Let me know when you stop hearing me. Okay. Types of sampling. Okay. All right, beautiful. Let's head back. Okay. Now, like I said earlier, in these types of sampling, we have random sampling when you are to take anything by chance. That's random sampling, taking things by chance. For example, I remember I said maybe in a basket of 12 colored balls, in a basket of 12 colored balls, right? And you are asked to pick 5 balls out of the 12. When you dip your hand and you close your eyes and you roll and pick one, that's random sampling. You are picking by chance, whatever comes. You are not systematic. You are not picking, you are not systematic. The opposite of random is systematic. You are not picking by chance. You have a kind of data you are looking for. You have certain aspect of data and the way you need to arrange them and pick them. That is systematic. Then stratified is an aspect where you put them in a certain order, in a certain strata, in a certain order. Then quota is in an aspect where you give a certain number to each. Okay, this particular area, and we are going to get 5,000 number of persons from here. There we are giving 3,000 based on population. Maybe in that the population is 10,000, we are taking 3,000. Here the population is 20,000 or 15,000, we are taking 5,000, and that's quota system. That's quota. So in types of sampling, we have 4 major types of sampling, which are random, by chance, stratified by strata, and then systematic by order, following a certain order, and then quota. These are 4 types of sampling. All right. Now having established that leads us to move to statistical significance. And in statistical significance, we need to first define what is statistical significance. And that is where we said here that statistical significance is an aspect in analysis that we use in hypothesis, estimation of parameters, under the inferential statistics or inferential analysis to check whether our claim, our statement, our hypothesis is true or not. Is what we use to indicate, to check whether our result, whether our decision, whether we are going to accept the hypothesis or not based on our result. So that's why I say here indicates whether the results observed in the study are unlikely to have occurred by a random chance alone. In other words, whether this thing that happened, Is it something that is significant, or something is just happened by chance, it's just a fluke? We need to analyze to check that statistical significance. If the result is statistically significant, now it says if a result is statistically significant, it suggests that the effect, the relationship, the difference observed in the data is likely real. So what that means is that if there is significance, then that particular event, that particular occurrence, that particular effect, relationship is not a fluke. It doesn't happen by random chance. It's something that can happen anytime. It's something that is significant. So how do we check that as an analyst? There is what we call level of significance. In analysis, the level of significance is a value to which you will compare your result to know whether you are to accept it as something that is statistically significant or not. We refer to it as level of significance, alpha. So statistical significance is a tool in analysis which we use to validate our claim. When you state a hypothesis, you are making a claim. So statistical significance, in that refers to level of significance, we use it to validate our claim, our hypothesis, to know whether we can accept it or not. So that is the aspect, that is the one in statistical significance. Then we move to types of, after statistical significance rather, we look at types of hypothesis. Hypothesis is making a statement of facts, and we know whether we are going to accept that statement, that assumption, that claim or not. So in hypothesis, there are two types of hypothesis. The first one is what we call null hypothesis. And as an analyst, as a researcher, as an analyst, you start from null hypothesis. What does null hypothesis say? Null hypothesis is saying that there is no statistical significance. There is no significance. There is no statistical significance. In other words, what null hypothesis is saying is that this thing happens by chance. It's just a fluke. There is nothing. It doesn't hold water. Don't mind it. It's not important. There is no. It doesn't have any effect, Jared. There is no relationship. There is no impact. It will not cause any significant damage. That's what null hypothesis. Can we hear me? Someone is saying the voice is breaking. Let's confirm. Can we hear me? Someone is saying the voice is breaking. Let's confirm. Let's confirm if it's from my end or from the person's end. Confirm if you can hear me. Someone is saying the voice is breaking. Confirm if it's from my end or are we good to go? Okay, someone says he has gone again. No, I'm here. I'm not gone anywhere. I'm here. We can hear you. Okay, I can hear you. We can hear you now, sir. Okay, he's back now, boys. It was shaking. Okay, tonight it has. Are you sure it's my network or your side? Okay, Precious Chidinma said I can hear you. Okay, let's proceed. I need to explain. Let me recap. Null hypothesis come from the assumption or come from the statement that there is no effect, there is no impact, there is no relationship, there is no significant difference, there is no that whatever happens by chance. It's not something we should take serious. It's not something of importance. That's what null hypothesis is talking about. And as an analyst, as a researcher, it's a default assumption. you start from null hypothesis. So that's null hypothesis, then which we represent with H naught. The second type of hypothesis is what we refer to as alternate hypothesis. Alternate. This, I forgot to take this to the back, is blocking certain things, this arrow, but is alternate hypothesis. That's the opposite of null hypothesis. Why null is saying there is no significance, alternate is saying there is significance. So note that null is saying no significance, alternate is saying there is significance. That's just that. So is the hypothesis that there is an effect or a difference. Not just effect. Please, I need to state this clear. Not just that there is effect, not just that there is difference, but whether that effect or that difference, whether it's something that we can take serious, whether it's something that is significant. That's what the alternate is saying, that there is significant effect, there is significant difference, there is significant damage, there is significant interaction, there is significant impact. While null is saying there is no. So these are two types of hypotheses, and then these hypotheses are based on statistical significance, whether it's significant or not. That's why I bring both of them all together in this explanation. All right, let's quickly wrap up this session this night by finally talking about data collection. Now, in data collection, we are going to be looking at sources of data. Where do we get our data from? Under data collection, sources of data. We are going to be rounding up quickly. In few minutes, we will be rounding up this section. And before we do that, those of us on this section, please, your scholarship ID, your name, your location, and your scholarship ID, very much appreciated, very much. Your name, your scholarship ID. Your name, your scholarship ID. Much appreciated. We are about to wrap up tonight's section. Okay, sources of data. There are two sources. There are two major sources. All different sources you will get data from is summarized into two, are grouped into two. Two sources of data, they are grouped into two. Because of time, I will not say, let me ask us who can get it. The first one is primary source. That's the first one, primary source. Primary source is the source of primary data. Now, in data category, there is what we call primary data. I need to explain that to us. In classes of data, we classify data into two classes. Primary data. Now, what are primary data? They are data that has not been used for any purpose before. They are data that has not been used for any purpose. In fact, first-hand data. When we talk about first-hand, when we talk about brand new product, in other words, from manufacturer to the person that is, it has not been used before. The same way in primary data. Primary data are data that has not been used for any other purpose. For example, you are doing a research and you prepare your questionnaire, get into the field, collect questions from the field, collect responses from the field. Those responses you collected are primary data. They are data that has not been used by anybody before. You are the one that is getting it firsthand. We refer to it as primary data. Thank you, Bible versus daily, that's primary and secondary source. Thank you. So when we now talk about primary source is the source of the primary data. Anywhere you got your primary data from becomes your primary source. If you get into the farm and you observe your chickens, you observe your farm products and what have you, those observations, those data you got from that is a primary data. So, and that farm becomes the primary source. So primary source is the source of the primary data. Then the next one is secondary, which all of us, we can also know that secondary data that has been used before, opposite of primary data. So secondary data is data that has been used before. So anywhere you get secondary data becomes your secondary source. So sources like from the internet, from AI, because those information you get from AI, most of it is a used data. AI, newspaper, websites, institutions, once you get data from there, they are all secondary sources. Why? Because they are secondary data. They are secondary data. All right. Okay. Next is we are going to be looking at data collection method. There are different methods of collecting data. I'm not going to do so much on that. I'm just going to list them out. Survey and questionnaire. Most of us have done this one, sharing survey and questionnaire. Then we have interviews. It's a method of data collection. While questionnaire is written interview, a written questions interview. Interview is an oral questioning. A questionnaire is a question from the analyst to the respondent. Okay. Interview. Then focus group is also part of data collection method. Observation, like I talked about earlier, observing your files, your farm, also is a method of data collection. Experiments is a method of data collection. Case studies, a method of data collection. Document analysis, trying to check your documents and that. Web scraping, this we do that in web analytics. And then it's a way of collecting data like those that uses cookies and all that, online tracking. These are different methods of data collection. These are different methods of data collection. All right. Then we now have ethical consideration in data collection. Ethical consideration in data collection. One of them, informed consent. The person you are using the data need to be informed, know what the data is for, what is going to be used for, and the person need to give his or her own consent for that information to be used for that purpose. Then another ethical consideration is privacy and confidentiality. Understand data privacy and confidentiality law, and then ensure to keep person's data private, and then use it for the purpose to which is being needed. So privacy and confidentiality is another ethical consideration in data collection, because some of us might be going into the field to collect data and that. Remember, privacy law and confidentiality. If not, you might be jailed for it. Respect for persons. In data collection, you need to acknowledge culture. You need to acknowledge persons, elderly persons, and that respect for persons is very, very important part of it. Consent in digital and online research. So people need to, when you are engaging in online research, digital, that's why sometimes you need to, when you are installing a particular software, Facebook and that, you need to give consent. They will tell you, allow this software to use your camera, allow this to use this and that. You give consent to that before they be able to get into your phone and then use your phone camera and all that. So consent in digital and online research. These are then data use and sharing. You need to understand the law of data use and sharing. How, whether it's allowed to share person's information as or not, or to use person's data. In what way, in what aspect are you allowed to use certain information, certain data? So these are ethical considerations. You need to understand that different countries and different legal terms. Here is compliance to legal and institutional requirements. There was a time Nigeria was saying Facebook and all that, give Facebook sanction and all that based on breach in some data privacy law, in all that. So legal compliance and institutional requirements. These are, you need to understand them as well. The next one is transparency and accountability. The person need to know what they get, the information he or she is giving, what is going to be used for. Transparency and accountability, and then we use it for such information as well. So as we progress, your name, your scholarship ID, please, and your location. Thank you. That's the attendance, the last attendance for tonight. Then we have what we call special considerations for vulnerable populations, and then we come to the end of tonight's section. I want to say thank you for being with me up to this time. Thank you for sticking around. Thank you for commencing this journey on data analysis. On Thursday, we are going to begin to demystify Microsoft Excel and to unravel things. We are going to be starting from the scratch of scratch, and some of us that think we know certain things, we will definitely learn certain new stuff as regards to Excel. On Thursday, we are going to be starting powerfully well from Excel basics, from what Excel is to the things Excel can do, explaining the interface. Thank you, everyone. Hope to see you once again Thursday for another section. And please note that every week, like we have said, there will be weekly project assignments that we will be required to do and submit as the project, as the course, and as the scholarship progresses. Your project assignments and your capstone project are the key gateways to you becoming a certified professional data analyst. Thank you, everyone, for being with me to tonight's section. Keep it up, comment your name, your scholarship ID. And at the same time, let me get our feedback. How is the section tonight? What did you learn? Give that feedback. Let's get that feedback from you. Let's get that feedback from you. How is tonight's section? What did you learn from tonight's section? How is it? Let me get the feedback from us while we wrap it up. Thank you. Your feedback, your review, much appreciated. If you enjoyed this session tonight, why not give me my flowers? Let me know that yes, you truly enjoyed the section tonight. Give me my flowers and let me get that. It goes a long way to motivate us, to encourage us to keep on dishing more. Thank you, Nance. You said I learned a lot. Beautiful, beautiful. If you are here, drop your name, your scholarship ID, and give me your review. All right. Ohiri Blessing says it was an interesting class and beautiful. Thank you for such feedback. Olawela Adeyemi, you say it was commendable, sir. God bless you. I appreciate that. We are precious. I received that flower. I receive it. Thank you. That much appreciated. All right. Once again, good night. See you all on Thursday. I guarantee you it's going to be amazing. You will not, in fact, let me wait till Thursday. It's going to be amazing. All right, good night, everyone. And do enjoy your night rest. See you on Thursday. I remain your facilitator and your host, Mr. Franklin.